Let knowledge flow like a river without any hindrance. Don't make it like a stagnant pool. Hello young civil engineers. I am P.S. Chatterjee. You are welcome to my new discussion. Test of Concrete Part 2. Based on flow test of concrete as per IS 456-2000. Today, we're diving into the ocean of construction together. While you may have theoretical knowledge, nothing beats hands-on experience, right? That's why I'm here to virtually guide you through some of the most important tests in the world of concrete. Consider this your lifebuoy, saving you from any fumbling along the way. If you're new, start from part 1 for more information. I hope you are going to enjoy this video. Before we begin, remember to like, share, and subscribe to my channel. Structural Design Only, a channel with a different vision, dedicated to structural design and a complete resource for civil engineers. The relationship between slump and flow diameter. In my video, IS 456-2000 Clause 7 Part 13, I have already discussed that flowability in concrete refers to its ability to flow and spread easily without segregation or excessive resistance during placement. It is a critical property that affects the workability and quality of concrete, particularly in applications where the concrete needs to be poured into intricate forms or around congested reinforcement. Flow diameter is the index of flowability, and it is directly proportional to the slump. The relationship between slump and flow diameter in concrete can vary depending on factors such as mix design, aggregate properties, and workability requirements. However, as a general approximation, the flow diameter of concrete is often roughly 1.5 to 2 times the slump value. In my video, IS 456-2000, Clause 7 Part 13, I've already discussed essential terms like blinding concrete, shallow sections, beams, walls, columns, slip-form work, pumped concrete, and in-situ piling. These terms are fundamental in understanding concrete construction. For example, blinding concrete provides a smooth surface for construction. Shallow sections include footings, slabs, and pavements. Beams, walls, and columns are structural elements. Slip-form work involves continuous construction, and pumped concrete uses specialized equipment. In-situ piling provides structural support. Now, before diving into concrete flow tests, it's crucial to know the corresponding minimum slump values and flow diameter for these applications. This information helps gauge the workability and fluidity of concrete. For instance, blinding concrete typically requires a minimum slump of 25 mm to 75 mm and has an expected flow diameter of 200 mm to 300 mm. Shallow sections might need 50 to 100 mm slump and 75 mm to 200 mm flow diameter, and so forth. Understanding these values sets the stage for comprehending concrete flow tests. Blinding concrete. Now the question is, what is blinding concrete? Blinding concrete, also known as lean concrete or binding concrete, is a layer of concrete placed on the ground to provide a smooth surface for the construction of foundations, slabs, or pavements. It is typically of lower strength and thickness compared to structural concrete. The slump of blinding concrete is usually in the range of 25 mm to 75 mm. The flow diameter of blinding concrete is typically around 200 mm to 300 mm. Shallow sections typically refers to footings, slabs, or pavements where the depth of concrete is not significant. The slump of shallow sections is usually in the range of 25 mm to 75 mm. The flow diameter of shallow sections concrete is typically around 200 mm to 300 mm. I think it is not required to explain what is beams, walls, columns, etc. Value of slump for beams, walls, columns, etc. 50 to 100 mm. Expected flow diameter is typically around 75 mm to 200 mm. For heavily reinforced sections in slabs, beams, walls, columns, slip-form work required slump 75 mm to 100 mm. The flow diameter of the concrete typically ranges from approximately 112 mm to 200 mm. Now the question is, what is slip-form work? Slip-form work is a construction method where a formwork system moves vertically as concrete is poured, allowing continuous construction of vertical structures like towers and silos without the need for fixed forms. Slump for pumped concrete 100 mm to 150 mm and flow diameter 200 mm to 400 mm. Now the question is, what is pumped concrete? Pumped concrete, also known as ready-mix concrete, is a type of concrete that is transported and placed at the construction site using specialized equipment called concrete pumps. For in-situ piling, tree concrete work required slump 150 mm to 200 mm. Flow diameter, for in-situ piling, tree concrete work required slump 225 mm to 400 mm. Now the question is, what is in-situ piling? Involves the process of constructing piles directly at the construction site by drilling holes into the ground and filling them with concrete or other materials to provide structural support. Tree concrete is a method used for placing concrete underwater or in deep excavations, where a vertical pipe called a tree is used to pour concrete from the bottom up, preventing segregation and ensuring proper placement. Flow test of concrete, Trial 1. This is my first slide of our discussion on flow test. You'll notice a worker placing a clean slump cone upside down at the center of a circle drawn on the flow table. This circle represents the estimated flow diameter of the concrete being tested. In the second slide, you'll observe one worker firmly holding the slump cone in place, ensuring its stability and proper positioning. Meanwhile, another worker is carefully pouring concrete into the slump cone with the help of spatulas. This coordinated effort is crucial to maintain accuracy and consistency in the flow test process. After filling, they are leveling the top using a trowel. In flow tests, there's no need for tamping the concrete with a tamping rod. Now, they will wait for 10 seconds, and then carefully pull the cone upwards to complete the test. As depicted in the third slide, upon pulling the slump cone upward, the concrete exhibited a failure to adequately cover the pre-marked circular area. This observation underscores the unsuitability of concrete for fulfilling the specific requirements of this construction project. Flow test of concrete, Trial 2. This is our slide 4. After the unsatisfactory outcome of the initial trial, as evidenced in the preceding slide, the subsequent slide illustrates preparations for the next trial. Here, after following adjustments to the concrete mix, workers are seen gearing up for trial 2, emphasizing the flow test of concrete. It's important to note that they will need to repeat all the previous steps outlined in my presentation on the flow test of concrete, trial 1. Moving on to slide number 5, we can see that the concrete now effectively covers the entire demarcated circular area, marking the attainment of their long sought after concrete consistency, showcasing the ultimate success of their efforts. And with that, we conclude the test of concrete, part 2. I trust you found this video informative and engaging. Stay tuned for my next video, which will delve into Clause 8, Durability of Concrete. Remember to subscribe to my channel for more content like this. Your likes, shares, subscriptions, and comments serve as great motivation for me to keep creating. Thank you for watching.